Welcome to EDU World Space.
We have a histogram and a box plot, and we want to look at the information we can get about the dataset from these two graphs. So let me start by kind of looking at them. So for the histogram, we have a series of bars that are touching because the dataset is going to be continuous. Looks like this. And the box plot gives you a very kind of clear set of information. It gives you the minimum, it gives you the maximum, I put this in quotation marks for a reason, and the first, third quartiles, and the median or second quartile. So it kind of splits your data up into quarters, because the first quartile is the value where a quarter is below it, so a quarter between first quartile and the minimum. The median is the halfway point, so half below, half above. So this is my second quarter between the Q1 and Q2 values. Third quartile has 25% above, 75% below. So that's the third quarter, and the last quarter up to the maximum. Now we have some extra little dots here. These represent outliers. Sometimes they ask you to clean your data set, which means you say the outliers don't matter, there's some kind of mistake, you just get rid of them. Sometimes you include them, because if they're not a mistake, they could be very influential for your dataset. So the true maximum would be up here, the highest outlier. Okay, so for part A, what features can you get from both of them? Let's start with A. Can you see if there are no values between 4,000 and 5,000? So on the histogram, you can very clearly see that. There's just 0 between those. Can you see it on the box plot? Well, because we've got outliers, yeah, we can see that. 4,000 and 5,000 is in this space between some of the outliers. So I can see that, so we'll put A. The distribution is multimodal. Is it? Well, if I look at the histogram, it is not. The mode is the most frequent piece of data. On a histogram, it's represented by the peak of the curve. So if I draw it like that, well, there's only one peak here. This is unimodal. I can see that from the histogram. So I can ignore that. Okay, see, the distribution is unimodal. As I said, I can see that on the histogram. Can I see it on the box plot? No, I have no idea how many modes there are just based on the box plots. I can very easily pick out the quartiles and the median, but I cannot see the mode. So C won't be the answer, D also can't be. Okay, what about skew? So skew on a histogram, if I again draw this, here, I can see a right skew, because we've got this long right tail. Most of the values are quite low, and then we've got a few out here. So this shows a right skew. Can I see that on the box plot? Yes. You look at how spread out these quarters are. Here, if I look at the first 2 quarters, they're very tight. There's not much space between them. And then the third quarter and the fourth quarter are much more spread out. That reflects a skew. So in both of them, I can see a right skew. We'll ignore E because it's not a left skew. Left skew would be this shape on the histogram, or this kind of shape on a box plot. You can see a long left tail. The mean is approximately 695. Is it? The mean is what you get. Mu is what you get when you take every value, you add all of them up, you divide by the total. So this makes it very susceptible to outliers, because every value has an equal say in what the mean ends up being. So if I look at my histogram, I would not expect the mean to be as low as 695. I would expect it to be a little bit further along. And for the box plot, I can't see the mean, but I can see the median. I can see the median is at about 700. And when you have a right skew, because the mean is being dragged up by those outliers and the skew, the mean would be higher than that. So I don't think the mean is 695 at all. We can't get a great read on what it actually is, but considering the median is about that, the mean is going to be higher than that. So I can ignore that answer. Are there 4 potential outliers? So this is an answer. On the box plot, they're actually labelled. They're dots instead of part of a box, so it's extremely clear. On the histogram, you notice outliers. because they're out on their own. They're not with the main set of data. You've got a gap, and then you have your outliers. So you can see them. Distribution isn't symmetric, it is skewed to the right. Is it the case that there are no values between 2400 and 2800? So looking at the histogram, that would be this gap here. Looking at the box plot, is that in outlier territory? Yes, it is, so we can see that. Okay, part B. What features can we see in the histogram but not in the box plot? The mean we've covered, don't think that's mean. Skew we've covered, C we've covered. Okay, D, the unimodal nature is something you see in the histogram but you cannot see in the box plot. Okay, and part C. What statistic would I use to summarize the center? I would want to use the median, because the distribution is skewed with outliers. So as I said, the skew and the outliers are going to affect the mean and make it a less accurate measure of center. It gives you a false idea of what the distribution might look like. Whereas the median is going to be in this bulk of the data set. What about the measure of spread? So again, the kind of typical is the standard deviation. Mean and standard deviation go very well together. Standard deviation is the average distance between data points and the mean. But again, it's the average distance. The outliers are going to massively increase the standard deviation. So instead, we use the interquartile range, which is the range of the middle 50%. Third quartile minus first quartile. And for the same reason, skewed with outliers.